Hi guys, this is Mr. Lee with another quick video. This video is on solving triangles. So let's think about all the strategies we learned in this chapter for solving triangles. First of all, if we have a right triangle, we learned 4 strategies. The first was the Pythagorean theorem, a squared plus b squared equals c squared. We use that when we have a right triangle when we're given 2 sides and we're solving for the third. Then we learned strategies for special right triangles. If we are given a 30-60-90 or a 45-45-90 special right triangle, then we know we've memorized some special relationships between the sides. Next, we learned straight trigonometry, sine, cosine, and tangent. We learned that we can use sine, cosine, and tangent if we're given a right triangle where we know one angle on one side and we're solving for another side. We learned to use inverse trig, inverse sine, cosine, and tangent if we're solving a right triangle for an unknown angle. Finally, we concluded the chapter by learning the law of sines, which we applied to solving triangles that are not right triangles. So go ahead and take a look at these 3 triangles and pause the video and see if you can figure out which strategy or strategies would you use to solve these triangles. Okay, this first triangle right here. Don't be fooled by the root 3. That root 3 automatically makes us think of 30-60-90s and special right triangles. But we don't know that this is a special right triangle. In fact, we don't even know that this is a right triangle at all. There's no right angle sign. So what strategy would we use? Well, we're going to use law of sines. Okay, so how would you actually use law of sines for this problem? The first thing that I would do is label the vertices and the sides. And recall that the labeling, the side corresponds to the opposite angle. So the side, opposite angle, side, opposite angle. Okay? Then the law of sines is just a proportion which sets up the ratio of the angle with its opposite side. So sine of A over A is equal to sine of B over B. And then if we just substitute in the actual values, we have sine of 42 degrees over root 3 is equal to sine of B, which we don't know that angle, over 5. And then how would we actually get the measure of angle B? We just multiply both sides of the equation by 5. So sine of B is equal to 5 times sine 42 over root 3. Okay. Go ahead and figure out what that is. Figure out on your trig table what sine of 42 is. Then multiply it by 5, then divide it by root 3. And then you have to take the inverse. So the measure of angle B is equal to the inverse sine of this whole thing. Okay, and I'm not going to do any more for you on this video. I'll let you go ahead and solve that on your own. Okay. Now we get to this triangle, and we notice that it is a right triangle. So how do we solve this right triangle? Well, we can solve for this side by using the Pythagorean theorem. So if we call this x, we know that x squared plus 6 squared equals 11 squared. And I'm not going to solve that for you on the video. You can pause the video and figure out what x equals. How do we get one of these acute angles? We only need one of them because the other one is just going to be the complement of it. Okay, so if we wanted to solve for this angle, use the 2 given angles, or the 2 given sides, to solve for this angle. Let's call the measure of this angle theta. And from here, we know that this is the opposite, and this is the hypotenuse. So sine theta equals 6 over 11. Then you just have to do a little bit of inverse trig to figure out what theta equals. Let's finally go to this triangle, and don't be fooled by the root 3. This is not a 30-60-90 special right triangle. It is special though, and it is right. It's a 45-45-90. We know that because the 2 sides are congruent, and the base angles theorem tells us that when we have an isosceles triangle, the base angles also congruent. So how do we go from hypotenuse to one of the legs? We divide by, because it's smaller, the leg is smaller, so we divide by root 2. And then how do we simplify this expression? Remember, we can't have a radical in the denominator, so we multiply by root 2 over root 2. And you can do the rest of that on your own, and make sure you simplify, and have fun. We'll see you next time.